Okay, let me say it again because I didn't record it. Okay, now I'm recording it. Okay, starting with the first one, if we have a fraction, which you're going to have a lot, you're going to have it, as a matter of fact, you're going to have a fraction all the time. If you have a number and you find sine or cosine or tangent and you get 10 over 12, you're not going to see 10 over 12 in the answer. Make sure you reduce, you're going to get 5 over 6, right? Always look to reduce. But what we're going to really focus more on is radicals. You're going to have a lot of these that are going to have radicals. Okay, number 2. What if you have an answer and you put, and then you get like 6 root 5 over 2. When you check your answer, it's not going to say 6 root 5 over 2. Anybody know why? Yeah, look at the whole numbers. Never the radical, but always look at the whole numbers first. Can you reduce the whole numbers? Yeah. We kind of saw that today in the warm-up, in the Padlet. What's gonna be the answer? 3 root 5. See? When you have a radical in the numerator, you're fine. We're okay with it. The problem is, and we've seen this before, you can't have a radical in the denominator. Okay? Everybody good with that one? Okay, number 3. What if you have 8 root 6 over 12? That's not going to be the answer when you check it. Right? Always look to see if the whole numbers first. Yes? Look at the whole numbers. And can those reduce?
Yes, by 4.
By 2, yeah, but also by 4. Okay, by 4 will be 2 root 6. 4 goes into 8 twice, and 4 goes... Okay, so it'll look like this. So you'll get this, and then when you go check the answer, it looks like this, and you're going to be like, why? What did I do? Why is it different? No, well, you didn't reduce. Okay, that's going to be the scenario that's going to happen. Okay, here's another one. Ready? Now, what if you have this? Number 4. What if you have 7 over root 2? See, this is what I'm talking about. We've seen this before. You can't have this. Can't have a radical in the denominator. Cannot have a square root in the denominator. Remember now what we had to do? Denominator. Can't have it. Cannot have a square. You can't leave. If you look at this, I mean, if you get this, like sine is opposite over hypotenuse or whatever, and then you go, it's not going to say that. Okay, so what do we have to do? We have to fix this. Remember how we learned to fix it? We multiply what? We multiply by whatever the same square root of 2 is. You multiply top and bottom by the square root of 2, square root of 2. All right. What's that going to give you? That's going to be 7 root 2 over 2. See, you'll have this answer, and then when you look on the book, it'll say this, or the worksheet, and you're like, that's not the same. Well, yeah, after you fix it, it's going to look like that. That's the part you're going to need to be able to fix it when it has a square root in the denominator. Okay, number 5. Well, I'll put it over here. What if you have 10 over root 2? Is that one okay? Yeah, you can't have any square root of anything in the bottom. You can't have the square root. So we got to fix this. And then when you fix it, the answer is going to look totally different. Finished? Let's see. 10 square root of 2. Oh, multiply by the square root of 2 and multiply by the square root of 2. Correct. What's that going to be? You're going to get 10 root 2 because that's the top. The numerator is 10 root 2. And then this is just going to be 2, right? That's your final answer? No. You didn't look again. Look here. Look at the whole number. See, that's not your final answer.
What?
Your final answer is what? The 10 and the 2 can divide. The final answer is 5 root 2. You see, these don't look the same, but they have the same value. If you go to the calculator and you put 10 divided by the square root of 2, you look at that number, and then you put 5 times the square root of 2. It's exactly the same number. Okay? It's the same value. It's like if I give you 4 quarters, it's $1. And if I give you 10 dimes, it doesn't look like 4 quarters. 10 dimes does not look like 4 quarters. But it has the same value. That's what I'm telling you here. You're going to get an answer like this, and when you look at the answer in the worksheet, it's going to say this. You think you did it totally wrong. No, you didn't do it wrong. You just have to fix the answer, because it can have a square root in the denominator. All right, let's do another one. Number 6. Number 6. How about 9 over the square root of 6? Yeah, we're only focusing when the square root is in the bottom. If it's in the top, you don't have to change it. If it's in the top, it's fine. But only when it's in the denominator, we have to fix it. We have to fix this. This is not right. So that is what? Multiply top and bottom by the square root of 6 and the square root of 6. Okay. What's that going to give you? Well, the numerator is 9 root 6 over 6. Yeah. What do you think? That's it? No, look again. Now that you got these whole numbers, look again right here. Can those reduce? Yeah, only the whole numbers. That can reduce again. So that's going to actually be by 3. 3 root 6 over 2, right? You see, this and this hold the same value. It's just that you can't leave it looking like this. So you got to do this. You got to do this business and fix it and do this. Okay, we're warmed up. We're good? All right. How about this one? Number 7. 1 over the square root of 2. No. I dyed it. It's my white shirt.
For St. Patrick's Day?
Huh?
For St. Patrick's Day?
No.
For Christmas, bro.
Oh, really? For Christmas? I don't know that. I don't know it's Christmas.
Now you know.
I don't know for Christmas.
I only wear this shirt once a year.
For Christmas?
Everybody stop. You're funny when you're cool.
Thank you.
You're gonna
For Halloween.
Wow. You're white? I mean, stop.
Okay, did you guys get this? You should have 1 times square root. You don't have to write the 1, so it's just the square root of 2 over. Once you have a whole number down here, you're fine. You can have a square root in the top, but not in the bottom. 1 divided by square root of 2 is the same answer as the square root of 2 over 2. Let me check it. See, can I do that? Let me check that. I'll prove it. Let's see. 1 divided by parentheses the square root of 2, close the parentheses. All right, you guys remember that? That's this one. 1 over square root of 2 gives me this value. .707. You get 7071. You guys remember that? .7071. Okay, now let me do this one. Now let me do the square root of 2. Get that answer, and then divided by what? 2? You guys see it? Yeah. It's the same. It looks really different, but it's not. It's the same thing. Okay. All right. This one I think you're going to get wrong. Number 8. I hope not. 5 over 2 root 3. All right. Well, we have a square root in the bottom. We got to fix this. We cannot have any kind of radical in the bottom. Who can tell me what to multiply by?
Square root of 3.
What about the 2?
You don't need it. This is not the issue.
Is anybody going to multiply by 2 root 3? No, you don't have to. I'm okay. I don't have a problem with the whole number 2. I don't have a problem with the 5. Just multiply by what? The radical. Correct. You don't have to multiply by 2 root 3. Just the part with the radical. Correct. So when you multiply top and bottom by just root 3, that's going to be what? 5 root 3 on the top. And on the bottom, what happens here? And this is going to be 2 times 3? The 2 is this. Here's my 2, and these made a 3. So when they're together, that's 2 times 3. Everybody agree that's...
Yes.
All right, let's see. Okay.